Hi, everyone. Welcome back to Aspect Insights, your favorite live stream and podcast about Bazel and its ecosystem. If it's not your favorite, well, it is the only one. This is episode 11. Today, I'm going to be speaking with Daniel Wagner-Hall. He is one of the maintainers on Rust. He also happens to be the Rust expert who I go to when I run into trouble getting our stuff to compile. I've known Daniel for quite a while. We worked together at Google. He's worked on a lot of awesome projects, and I'm really excited to have him on the show today. Welcome, Daniel.
Hey, fantastic. Lovely to be here. I've been a long-time watcher, a first-time caller, I guess.
Oh, that's so cute. How are you doing? What have you been up to lately? What sort of introduction do you have for anybody who doesn't already know you?
Hi, I'm Daniel. I've been in the Bazel space and build space for a while. So as Alex said, we worked together at Google for a while. I was part of the team that open sourced Bazel originally. Jumped around a few build tools since, and I've been, as Alex said, kind of Rust maintainer for 4.5 years, something like that at this point. Last while, I've shifted away from kind of working full-time for a company towards kind of doing more consulting. So if you have weird Bazel-Rust needs or Bazel needs around to chat, and also doing a bunch of teaching. I teach with a charity called Code Your Future. We teach refugees and other kind of folks who have suffered setbacks in their lives to become software engineers. It's been a lot of fun and very rewarding.
That's awesome. I love that you've got your consulting thing going on. If folks do want to reach out to you for the kind of help you mentioned, how do you want them to reach you? Like Bazel Slack or email?
I'm on the Bazel Slack, Daniel Wagner-Hall. Ping me there. Always happy to have a chat.
Okay, cool. Well, I guess before we dive into today's material, I should have mentioned a couple of updates. The main one is, of course, BazelCon is coming up soon, and the wait list is growing. The total capacity of the venue is 400, and because it's a free event, it's hard to know who's actually going to show up. So 450 people were admitted. If you're not planning to come, if you've registered and now you're not so sure, please unregister. That's the only way that other people will be able to get off the wait list and into the Computer History Museum on October 14th. I think that's it for today. Let's talk about Rust. So Rust is a pretty popular programming language, I keep hearing. I know, for example, it's been the most loved on, I forget which of the surveys for the last several years in a row.
Great language. Allows you to avoid all sorts of problems that you'll run into if you're not paying careful attention to a lot of things.
Yes, and of course, since we're going to talk about Rust and Bazel, we don't really have time to talk about Rust's language features. So I'm sure there are many other podcasts. We can put some links in the show notes if those things are new to you and you're disappointed that we skip over it. But generally speaking, there's the way that you would do Rust if you were just following anybody's getting started guide or reading a Rust book. But then things under Bazel are always a little bit different. And in some cases, every language makes its own choices, right? So for Go, for example, there was a while where like the Go mod file was not the source of truth for Bazel. You would run some tool that would import all of those, and then in Bazel you would have like a dependencies.bzl file or they could even go in your workspace file. And so, of course, there's trade-offs there about like how much you expect the idiomatic Go tooling would work if Bazel was running alongside of it. So I think the first thing is under Rust, sort of how does that work? Like how compatible is it with non-Bazel?
Yeah, so it's a great question. First one people often come to when they're starting to use Bazel and Rust. And there's really two approaches you can take there. So one approach you can take, which I think most people do, Rust has its own kind of package manager build tool called Cargo. Most people, I think, try and keep their build completely compatible with Cargo. And so they lay their source code out in the way that Cargo would expect. They have all of the dependencies written down in their cargo.toml file. And with Bazel, we've tried really hard to have really good support for making that just work. And so your build files will work just fine if your files are laid out like Cargo. For our third-party kind of ecosystem support, you can just point it at your cargo.toml file, and it will use that as input to drive kind of how it resolves dependencies and fetches third-party packages, that kind of thing. Other folks sometimes want to go more Bazel first and want to maybe lay their code out in ways that Cargo wouldn't understand. They don't like that you're required to have a source directory for Cargo, and so they really want to get away from that. Or they start doing more complicated things with Bazel. Common things there are things like code generation. If you're doing code generation, like there is a way you can do that in Cargo, but if you're like wanting to write generals, or if you're wanting to like reuse code generation across multiple languages, you maybe want to shift more towards that Bazel-first approach. Things like protocol buffers, you kind of have to decide, do I want to do this the Cargo way or the Bazel way? If you do it the Cargo way, you can make it work in Bazel. It's probably harder to make the Bazel way work in Cargo. Some of the benefits of kind of keeping to the Cargo way are the rest of the developers on your team who maybe don't have Bazel experience are more likely to kind of just see how things work. And some external tooling kind of relies on that. So I think we'll talk in a bit about IDE support. IntelliJ and Rust Rover and kind of the JetBrains IDEs don't really have like Bazel native support. So if stuff happens to work with Cargo, those IDEs will just work out of the box. Whereas if you've deviated from that code layout, we have pretty good VS Code support. We have like an LSP implementation that allows that to work well, but certain external tooling is less likely to work if you're kind of leaning heavily into Bazel unique kind of features.
Okay, yeah, that makes sense. So that means that I would continue to use like the Cargo tool to like fetch dependencies, and it will update the Cargo toml file for me. Is that correct?
Yep. So you can use Cargo add, Cargo edit to kind of modify that. And when you do a Bazel build, Bazel will basically read that as the source of truth. If you're kind of locking your dependencies, then Bazel will go, whoa, something has changed. We need you to repin so that we can like reread that cargo.toml as input and work out what we should do. But transparently, if you're maintaining your Cargo world okay, the Bazel world should just work most of the time.
Okay, so that's cool. So for most users, they should kind of expect that adopting Bazel for Rust isn't necessarily scary. They can keep doing what they were doing before, unless they decide they really want to opt into the all the way Bazel model that you described. But that would be, yeah, you should take care before you make that decision. Okay. So Cargo, of course, is also responsible for actually downloading things, and I'm sure it has its own caches that are responsible for avoiding doing more downloads in the future. Bazel also kind of likes to be in charge of downloading things. So how does that one work?
So I think there's two sets of things that get kind of downloaded in terms of third-party dependencies. There's the metadata about what exists. So when you're doing kind of resolution of versions, you go, hey, I want some version of Tokyo. And Cargo will go, hey, these are the versions available. I'll pick a suitable one for you. So that metadata, we can share that cache with Cargo. And so we don't need to be doing a bunch of expensive index lookups if we don't want to. Then downloading the actual source code. As you said, Bazel kind of generally likes to own where it puts things. And so that's kind of a separate cache. But typically, you don't have a huge tree of dependencies. Like you have up to maybe 1,000 crates, and those are all kind of compressed source code. And so that typically isn't a lot of overhead for you to be re-downloading.
Okay. Yeah, well, I know that there's one other important detail, which is that not everything is pure Rust. People use for and function interfaces to reach into C++ for sure. So, like, does that mean that Bazel is responsible for downloading the C++ dependencies, or like, how does Cargo? How do you convince Cargo to be more hermetic under Bazel when it's dealing with those?
Yeah, it's a great question. It's honestly one of the most fiddly and the corner in the rule sets where we have to take the most care and do the most complexity. But we try and make that work pretty transparently to end users. So I think there's a few different ways that crates tend to depend on C++. Some of them just bundle the C++ with them. Like if you're depending on like bzip is like 3 files of C, and it's pretty trivial to compile. And so if you're depending on something that vendors that stuff in, that will probably just work out of the box. In particular, when we do the compilation for those things, we make sure the C++ toolchain you have configured is like exposed in the ways that crates tend to look. So we set the right environment variables, we make sure all the files are on the path so that like if you've configured a particular version of LLVM that you want to be using, that will be passed along to that compilation context. So for kind of simple things, it tends to just work. for more complicated things, like OpenSSL is a great example. The OpenSSL crate has a few different ways that you can configure it to find OpenSSL. It can try and compile it for you. It can try and find a pre-installed version that's kind of on your machine. And both of those can work, but we found that a lot of people actually, they're already compiling OpenSSL as a C++ library in their workspace. Like they're pulling in from the Bazel Central Registry or somewhere. So they're already building the C++ code they need with the tool chains and stuff they want through like some CC library rules or rules foreign CC or something like that. In a lot of cases, those crates have a hook that you can provide where you can specify an environment variable where you can say, hey, I have an OpenSSL over here. I'd like you to use it. And so we have these things called annotations in our kind of Bazel mod and our workspace integration where you can basically configure things and say, set this environment variable to point at wherever this like directory or this library is. You can add a dependency or a data dependency there. And so if you're already building some C++ in Bazel, you can say to rules Rust, like, I already have an OpenSSL, can you reuse this one? Which has a bunch of benefits. It means that you're going to reuse that cache. You're not going to have to build OpenSSL twice. You can maybe get remote caching if you have like a remote execution set up. And so maybe you don't have to build an OpenSSL at all. You can just grab one from a cache. So typically one of those two things tends to work. Every now and then we run into a crate in the ecosystem that like both doesn't compile a thing and doesn't have a hook. Like it hard codes, I'm going to run package config and try and find like a pre-installed thing. So every now and then, either we or we encourage our users to like file a feature request or a pull request to those crates to say, hey, it would be great if I could just override this with an environment variable. And we've had a decent amount of success in people in the ecosystem kind of picking that up. So generally the integration works pretty well. I'd say like 90% of the time, if you're doing something complicated, it will work out of the box. Like if you're doing something simple, like 99%, it'll just work. If you're doing something a little more complicated, 90% it will just work out of the box. Every now and then you need to kind of put in a little hook or customization, but that's all reasonably well documented. There's some examples in the rules Rust repo. It tends to work pretty well.
Wow. Okay, that's fantastic level of guidance. I love the percentages. So a couple of follow-up questions on that. One is, if I have a crate that's misbehaving, do you have a facility for me just to drop a patch file in my repo and tell rules Rust that I want that patch to be applied to the crate before, like after it's unpacked and before the contents are inspected?
I don't think we currently do, actually. So you can point at like a fork of it. So one thing you can do in a cargo toml file, just in ordinary Rust development, is you can say, instead of getting Tokyo from like the central registry, I would like you to fetch this from this Git repository at this tag, and I would like to use that as my Tokyo dependency. So you can do that in your cargo toml file, which will then be used by the rules Rust. But I don't think we currently have a way of just throwing in a patch file. It's probably a handy feature request, though.
Yeah, I think it would be great because I'm sure you've had this experience that it's easy to make a fork. You press a button on GitHub, and then it's easy to make the five line edit that you want. And then several months later, you come back and look, and your fork is completely different from upstream, and you like rebasing it looks impossible, and like that wasn't what you meant to happen. Patch files obviously sort of, by their nature, they express the deviation from upstream much more clearly. So yeah, okay, there you go. There's a feature request. The other question is, you mentioned remote caching and execution for building the C++ code. Having implemented a couple of these package manager integrations in Bazel, I know that there's a difference between repository rules and actual actions, right? So if something happens in a repository rule, it's kind of in this non-hermetic setup phase of Bazel where it can't use things like remote cache and execution. So like for JavaScript, for example, originally we let the package manager expand the archive files that were fetched, and then we switched that to do that inside of actions so that the lifecycle hooks could be cached and run remotely. So can you describe just very briefly sort of where's the split between repository rules and actions?
Yeah, absolutely. So we do what I think is kind of the general best practice in the Bazel community these days, which is our repository rule does the least it possibly can. All it's really doing is that really unhermetic stuff. So it's running cargo, it's doing that resolution of what exists, and it's generating some build files. And then at build time, we do all of that compilation. And so anything compilation-wise that we're doing is done at build time. The only things we're doing in the repository rule are basically working out what versions of what libraries need to exist and what features do they need enabled.
Okay, so that's interesting. Does the lock file that Cargo writes not give you all the information you need there?
The lock file unfortunately does not. The really big thing that the Cargo's native lock file is missing, well, there's two. One is we allow you to do these annotations, as I was describing earlier, like to say, hey, I want to use this OpenSSL from over here. So that's not in the lock file. That's something we need to customize ourselves somehow. But the big thing that the Cargo lock file is missing is that it currently acts as a superset of all the dependencies you could need. And so it doesn't have platform-specific information in. And so every Cargo lock file for any non-trivial project will have a bunch of Windows-specific dependencies in there, which you can identify because they're called like Win32 or WinSys or whatever. But there's no metadata in that lock file to say, hey, this is only needed if you're on Windows. And so that's one of the places where we really need this repository rule, is to resolve, like, if you're building for Linux, these are the things you need. If you're building for Mac, these are the things you need. Rather, where I think there has been some discussion about adding more information to that Cargo lock file that could allow us to kind of simplify this even further and maybe even get rid of most or all of that repository rule, but that's a ways into the future.
Got it. Okay, but it's good to know that the things that do exist in the Cargo lock file are reused under Bazel. So it's not like you're going to have Bazel drifting from, if you ran some tool outside of Bazel.
Yep, absolutely.
Yeah.
Okay, if you supply a Cargo lock file, we will pay attention to it as much as we can.
Okay. So obviously the main tool that you would run outside of Bazel is the IDE. So let's talk about that a little bit. So there's Rust Analyzer, which I think people use with VS Code. I don't know what you do with IntelliJ. I guess, what's their tool called?
They recently released an IDE called Rust Rover. Before that, just IntelliJ itself supported it, but they've kind of split out a Rust-specific IDE pretty recently.
Yeah. Okay. Cool. I see. So I guess you said earlier 90%, 99%. Sort of what's the percent of how much people should expect their editor continues or IDE continues to work?
That is a great question. So I think it goes back a bit to that first question of, am I staying the Bazel way? Am I staying the Cargo way? So if you're staying the Cargo way, everything should work. Everything will work because it's running things through Cargo. And so you're not going to benefit from like a build cache where you're sharing that Bazel has built stuff. You're not going to get, say, remote execution working and populating a cache there. But all of your IDE features will work because things are laid out in the way the IDE expects. If you've embraced more of a Bazel way, if you've moved around files where they're maybe not as expected, if you have code generation and stuff, Rust Analyzer support is pretty solid. It will have kind of autocomplete, it will have click-through, it will understand the structure of your code and your modules. I should probably give a shout out to, I think, David Barsky, who I think is a meta engineer working on Buck at the moment, has done a lot of work in Rust Analyzer to make it a lot more pluggable so that you can configure it and it can kind of detect things in non-standard locations. We benefit from all of that work. And so Rust Analyzer support is pretty good. The way that works is we have a target that you can run. This is all kind of in the docs. Basically, you run a target, it generates a project config file, which has all of the information that Rust Analyzer needs. And Rust Analyzer can then just run with that and go, hey, I understand where this code is. I understand the structure. I understand how I can navigate this. I'm not sure how tightly things like running tests and that kind of thing works in VS Code. But in general, there have been a bunch of folks in the community who have been improving that support over time. And we always are happy to review more and more kind of improvements to how that support is working. So yeah, VS Code will pretty solidly work, but maybe missing a few features like some of the really specific code intelligence, which we think can be added if people are motivated. The kind of JetBrains side at the moment is relying a lot more on Cargo compatibility. There is some hope there. So JetBrains have been experimenting a lot with something called the Build Server Protocol, or BSP. And the idea here is like your build tool knows everything it needs to know about how to build your code and how to run your tests and stuff. Historically, like IntelliJ has re-implemented most of that. And increasingly, some folks at JetBrains are kind of going, well, rather than us re-implementing this and sometimes it being different and sometimes it getting out of sync from the tools you're using, and us needing to like have conventions of how things are laid out, maybe build tools could just be the source of truth for this information. So the folks at IntelliJ have been kind of putting together an experimental build server protocol support, both on the Bazel side and the IntelliJ side. So as and when that matures, like that may be a really nice road forwards for Bazel support to kind of get more native in IntelliJ and for everything you'd expect to work. But I think there's still a bit of a journey for that to kind of stabilize and make it into the mainstream.
Yeah, I've been tracking that effort as well. It would be really great because not only would IntelliJ benefit, but Visual Studio Code or other editors can be, you know, the server side of that protocol, and then they can also collect that information. So you could really have the hub and spoke model you want, where you're implementing support for Bazel in one place, and now all the editors light up.
Yeah, and I mean, at the moment, that's been going really well in the Scala community. I think Scala kind of is where BSP got first prototyped, and that is how Scala works in VS Code, and it's really high quality. And so seeing that expand to more tools and more IDs would be a really exciting thing.
I forgot to mention earlier, we are, of course, we're live and taking questions. So if you're on YouTube or LinkedIn, please go ahead and ask questions. I noticed that Andre, your co-maintainer of Rules-Rust, is watching and helping fact check us a little bit. So hi, Andre.
Fantastic to see you, Andrew. And thanks for all of the things you've been doing, particularly recently around a bunch of edge cases around that third-party support. It's been wonderful to see.
Yeah, and anyone else, if you do have questions and you're on the live stream, please go ahead and ask. We'll try to leave a little time at the end. Okay, so let's switch gears and talk about compilation targets. So I know that, you know, one experience I've had shipping tools for customers is they say, oh, but I'm on Ubuntu 18 and my libc is like 2.26 and the thing explodes. You know, that's just Linux to Linux, you know, if I was building my tool and shipping it to my coworkers. But of course, we have developers who were shipped shiny Mac laptops and are trying to target Linux production environments. So let's talk a little bit about that. What do you think is what's the best practice to avoid those kind of problems?
Yeah, I think this is a corner that has some trade-offs, as with a lot of difficult things in software. So I think the problem you kind of described of where you build, you kind of link against a libc implementation, a specific version, kind of pushes people to be building on their CI on really old machines. So I've seen people who like are still running CentOS 6 machines or like Ubuntu 14 machines because they want maximum compatibility in what they build. There's some trade-offs there. It turns out maintaining like the CI image on like a 15-year-old OS isn't super fun and often isn't super secure. So an alternative that some folks have been using is using a kind of statically linking toolchain like Muscle or Zig to basically embed a more portable libc implementation and rely less on what happens to be installed on the machine, and kind of embed more of that information into more of those instructions into the binary that you're producing. Personally, I'm a big fan of those where they work. It means that you don't need to worry about, I built this thing, I send it to Alex, will it work on his machine? There are some risks and downsides there. The big one is that some libraries strongly assume that they're linking against the glibc. And so sometimes when they are called into, they will try and do something that just isn't there in the binary or on the machine that they're running on, which can cause some crashes and segfaults. Fortunately, generally in the Rust world, this isn't a big problem. Like unless you're writing a bunch of weird C code or linking against a bunch of kind of more niche C libraries, you don't tend to run into those issues. And so we have this working pretty well. We have like our CI tests out examples with this. So we've released also a muscle toolchain in the Bazel contrib org that you can fetch from the BCR, which supplies all of the C++ toolchains that you need to make this work. As I say, there's some examples in the Rules-Rust repos for how that works. I think we have a Zig example, but I think it's currently disabled because we need to like debug some stuff that was going on there. So in general, like that static linking, cross-compiling produces binaries that are more portable, more likely to work in a bunch of different places. Also that you can build across operating systems. So I'm on a Mac right now. I can use Muscle to build Linux binaries that I can then ship to Linux environments if I need to.
Right, and I guess part of the reason that most Rust code works with musl is that it's not like a strange esoteric science project. It is pretty common for people to target outside of Bazel, right?
Yeah, absolutely. Mostly for that static linking reason. Like you want to be able to produce a binary you can just hand to someone and trust that it will work the same for them as it did for you.
Yeah, static linking is definitely the best. Are most combinations of platforms supported? Like if I'm on if I'm on a Mac, I can build for Linux. If I'm on Linux, I can build for Mac. Like what about targeting Windows, that kind of thing? Like is the feature matrix kind of sparse, or is it populated all the way?
So for individual platforms, Linux is super well supported, Mac is super well supported. Windows, I think none of our maintainers on Rules-Rust are like heavy into Windows. And so we have CI, we try and fix stuff up where we can, but none of us are experts. And there's some interesting issues that get run into. The most common one is Windows has a maximum length of path, and Bazel tends to create temporary directories that are pretty well nested. So our Windows support is there. It works. There are people using it in production, but if you're going to run into an issue, that's probably where you're going to run into an issue. And then for cross-compiling, going from anything to Linux probably works pretty well. I'm not sure anyone has tried cross-compiling targeting Windows. If you do, get in touch. It'd be interesting to learn about. And I think compiling from Linux to a Mac, I think there are some toolkits out there that have been shown to work, but there are some questions around Apple's licensing terms as to how kosher those are to do. So I would encourage you to consult whatever lawyers you feel the need to consult before necessarily going down that path.
Yes, I believe you've just told me to yes, go talk to a lawyer. I'm definitely not going to do that. Just speaking for most developers there. Of course, personally, I would be happy to go discuss licensing. And Andre points out that some help on the Windows side would be really appreciated if anyone in the community can help. I should add a plug for a project that I'm trying to get started with the Rules Authors Special Interest Group, maybe in the next few months, is to make it much easier for any developer working in the Bazel ecosystem to just spin up a Windows backend and connect to it from their local editor, right? So, using remote editors is kind of a pretty convenient thing now with Visual Studio Code, and IntelliJ has something called Gateway, I think. So in theory, you should be able to just say, hey, some cloud, give me a Windows instance. I want Bazel to be installed there already, so I don't have to suffer. And then, yeah, I get like a command.exe terminal in my local editor.
Yeah, it would definitely help us debugging why is our CI failing. Round tripping through CI is not a beautiful experience for debugging minor issues.
Yeah, well, you mentioned David Zbarsky earlier. He was helping us out to get a fully statically linked BSD-tar executable, which we use from Bazel-lib. And yeah, I spent a day this week round tripping through Windows CI to figure out why we were accidentally publishing an ELF binary inside of a .exe, which does not work, it turns out. So you mentioned Bazel Central Registry earlier, and we only have a couple minutes. So let's, I'll just touch on these. So obviously Bazel-mod is the future. We had an earlier episode with Fabian Murmertime about that. That generally works with Rules-Rust, I assume?
Yep, generally works. We did a migration. We have people using it. Every now and then there's a really weird corner of one of the rules that hasn't been quite ported over fully. And so we're fixing up a few things as they come up, but should work. If it doesn't, come talk to us. It's expected to. Okay.
Cool. And then I think we talked a little bit about connecting with C++ earlier. Is there anything else that we should discuss there, related to linking or something, or interop with the rules CC?
Yeah, just throw in generally interop between languages is one of the places Bazel really shines at. If you want to depend on C++ from Rust, that should just work. If you want to depend on Rust from C++, that should just work. If you want to use Rust through JNI from Java, that should just work. And your build files are going to look the same in all those cases, right? You make a library, you make a binary, you have a dependency between the two, things just work. We have a bunch of examples of that in the Rules-Rust repo. But yeah, it's one of the selling points of Bazel. It's one of the things it's really good at, is crossing between languages natively is just a nice thing.
Yeah, well, I I was at Packaging Con last year, right after BazelCon, and there were some interesting talks about WebAssembly, which seemed like there are a lot of folks thinking that that's a very attractive way to get wide interop, include, not just on your machine, but also being able to run it in browsers or on mobile devices. My understanding is Rust has a very strong WebAssembly, story for being able to target that runtime. How well does that work?
People tell me it works. This is one of our corners. I say Andre also mentioned if anyone wants to come help out with Windows support in the community, we'd love that. I think WebAssembly and also BindGen are two corners where we have people using them. We occasionally have people filing issues about them because things are mostly working and they run into a corner. Whereas maintainers, we don't particularly have much experience with that. And so we have support for WASM, we have support for BindGen. Those things in theory work. But I couldn't tell you how well because I've never actually used them myself. And I suspect that's probably true for all of our maintainers. So if it's, again, something you're interested in, if it's something you have some expertise in, come have a chat. Let's see how we can help make that support better together.
Excellent. Yeah. I haven't tried that myself either yet, but I'm sure one of us will run into a customer who's got a really compelling use case for it, and that'll be our opportunity. A lot of these things, of course, squeaky wheel gets the oil, or the compelling use case gets the maintainer attention, especially in cases where we need to be sort of have your passion align with what somebody needs.
Absolutely.
Yeah, that'll be exciting. All right. Well, I think one other thing that I noticed is went to gRPConf last month, and there was a talk from somebody who works on Tonic, I believe. I keep confusing that one and Prost. That they are planning to bring that into gRPC, and actually, there's a Googler has committed on the gRPC team has committed to I forget some time frame for having first-class Rust support in gRPC, which it was not clear how much that meant that it's first-class support in protocol buffers, because those are two separate teams at Google. I don't know if you've seen any movement there or have anything to add.
I've definitely seen things are happening there. I've seen, like you said, there's some initial kind of code that's going in. It'll be very exciting to see how that goes. I think from the rules Rust side, there's an amount that a protocol buffer compiler plugin is just another plugin. And so we happen to have support for using the Prost and Tonic plugins right now. If there's another plugin that comes along, it should be pretty easy to just kind of drop in support for that. So not sure what the timelines are. It'll be interesting to see like what different trade-offs are made between the Google implementation and the kind of ones out in the community. But when it comes, we're looking forward to experimenting with it too.
Okay. Great. Yeah, I'm sure that hopefully that talk is published by now. I'm sure they did publish the talk videos. I remember they were recording them, so I imagine that for anybody who's interested in diving into that one, you can go find that talk. Okay, well, thank you so much for coming on today. We don't have any other questions in the chat, so I think that's all the questions I had planned for you.
Fantastic. Sounds fantastic. Yeah, I am looking forward to hopefully hearing from some new folks trying out the rule sets and seeing how they go.
Yeah, well, Rust is the most loved programming language, and Bazel is one of the loved build systems. So we definitely want to make them awesome together. So yeah, let's do it.
Fantastic.
Thanks,
thank you very much.
Okay, bye everybody. See you next time for episode 12.